Okay, a short pre-lab lecture for the experiment liquid-liquid miscibility. And the two liquids that you're using here in this experiment are cyclohexane and methanol. Get that straight. Here's our laser. What you should do when you come in is to turn the laser on so that it's warmed up. It should be plugged in already. And the little button to turn it on is in the back. Just press it. There we go. It's registering. You can see that over there on the piece of red paper. And I would suggest before you start making any solutions to just get all of your optics lined up. So make sure that the laser is in line with the stir plate and that you have the clamp located so that, and use an empty test tube. See the, have the clamp, sorry, so that the test tube, when it is full, you can just put it in there and tighten it and you know that everything is going to align. And then the stir bar is in it already as well. You want to also have the stir plate, just keep it on for the whole period, don't turn it on and off. And that way you can make sure that the setting doesn't change. And I would suggest a setting of 6. I suggest that, and that everybody should use the same setting just in case you wanted to use share data. So above 6, the little guy spins so fast that the vortex is too rough, too rigorous, and what happens is the laser beam ends up going through the not so smooth stirring of the liquid and it can get scattered. Okay, if you don't stir enough, phase separation can occur in localized regions of the sample, like say near the top where the stir bar vortex is not reaching. So there's our clean dry test tube, and you've got more test tubes over here in the box, and your supply of graduated pipettes, clean, are here. And I don't see any 1 mil pipettes. You probably want to ask for some of those as well. So you've read the manual and you see that the total volume in your test tube should be either 20 or 25 mils. I'm not recalling from memory, but you have your manual and you can check. And so you decide what combination of volumes of your two liquids will go together to create a mixture of the two liquids, which may or may not be miscible at room temperature with the proportions that you choose. And measure each liquid out with its own labeled graduated pipette, and don't use one for cyclohexane and then use it for methanol. So make sure these are labeled and everything in there to start with is clean. The dirty ones go over on a tray by the door. Okay, so once you have, let's actually undo this. Okay, once you've decided the volumes that you're going to use, put it in your test tube and then come over here. This bath will be on. And put it in the bath and just swirl it like this. Do not secure it at the bath and walk away, because what's going to happen, it's going to start to vaporize, and all that careful work you did to measure exactly what volume went into the test tube, not the flask, but test tube, is gone down the drain because some of the vapor is leaving and now you don't know exactly the composition anymore, and it's important that you do. So just swirl it around in this bath, because when it gets warm enough it's all going to be one phase, and then very quickly, we have to move fast because it could phase separate quickly. This is why you want this in place beforehand, and I'm doing this with one hand so it's tricky. Just going to let it sit, and at the same time my temperature probe should be inside the tube, which I can't manage by myself here. But when your test tube is over here in the bath, warming up to one phase, this temperature probe should already be inside and displaying the temperature. Okay. All right. Just so that it's ready. And so as this thing is stirring, you will have this in place. Okay, and don't put it in and walk away again, because if I let this sit, it's going to hit the laser beam and scatter it. So you can just hold it in place. There are 2 or 3 of you, so figure out whose job it is to do what. And let it sit there and cool down and record the temperature at which it phase separates, and that'll be the critical temperature. So why do we have a laser? The laser is going through your sample, right through the glass, and being projected on the wall over here. There we are. Because there is no phase separation going on here, of course, because there's no sample. But when your liquid, which originally starts as one phase, separates into 2 phases, it does so in very local domains, and those domains of the discontinuous phase, will scatter your laser beam. And so this little spot is going to get more diffuse as the temperature is cooling and as this thing is phase separating. At the point where that spot is completely gone, it is at that point where you record the temperature. So for some solutions, the phase separation is going to happen so quickly you'll wonder why you have the laser. But at another composition, the phase separation is going to happen so gradually that you'll be glad that you decided the point at which phase separation occurs is where the laser beam is completely scattered. So you'll be consistent. Now, once that is achieved, you can take this off, and before you put it in your organic waste, don't put it down the sink because it's methanol and cyclohexane. Why don't you test the precision of that? It's already made. Why don't you heat it up again, bring it to 1 phase. Again, my thermistor probe is already in here. And if you forget to put it in, that's okay, but make sure you wipe it off before you put it in again. The thing is, when you put in a cold thermistor probe into this solution, you might actually get some temporary local phase separation around the probe because it's colder. Okay, so it's then at a lower temperature. And let it sit and stir, and the laser go through, and your thermistor probe is in it, and again, record the temperature at the point when, in the cooling, when this laser beam is completely scattered. So if you look this way, there is also another setup over here. You guys can share the bath. But there's another laser going this way, and at the moment there's no paper on our splash guard, but you'll have a sheet of white paper so that you have 2 stations and another thermistor probe there. So pretty straightforward. Your instructor will give you some pointers on what compositions you should try and others which are more difficult and might want to be avoided, but I'll let them deliver that information. So remember, nothing goes down the sink, and if you are keeping some of your stock solution or stock solvents over here, please keep them in labeled clean beakers and with watch glasses on top so nothing escapes. No measurements should be done using a grad cylinder. That shouldn't even be there. Everything is done with volumetric pipettes, and the dirty pipettes should be placed on a tray somewhere over here near the door. All right, don't look at the laser and be careful. If the laser moves and it hits something metal, it can reflect back. So please exercise a lot of caution with the laser. Okay, have fun.